Like the physicists, astronomers, and cosmologists before me, I've left the hardest problem to the last. That problem is, how do you get action at a distance, which is commonly known as gravity. So in previous videos, we've seen that each isolated object in the triangular neighborhood syntax has 12 five-edge nodes somewhere on the surface. In a previous video, we've seen how defect motion changes the structure of a triangular neighborhood network. Here are a few states of the simulation that we've seen before. But supposing the problem really was that we wanted to be able to have the object, in this case a scaled icosahedron, be in constant motion like this, so as to eliminate the notion that it was in fact an icosahedron. Well, maybe that's not the purpose, but it would be the effect. So how would we achieve this effect? Clearly the defect motion, as we see once again occurring here along the surface of the fabric of the triangular neighborhood network, is a rather slow and curious process that leads to all sorts of distortions. How would we keep the basic structure of the icosahedron complete and yet be able to move the five-edged nodes around the structure in a systematic fashion? Here is an interesting toroidal hole that has 7-edge nodes on one side, 6 of them, and a hexagonal interface. And then on the other side it has 8-edge nodes with a triangular interface. So all told, in this structure, there are, as in every toroidal hole, a positive curvature of plus 12. This is in contrast to an icosahedron that has a negative curvature of 12. This is a section of a pipe of a particular construction. You can see the toroidal hole embedded in the pipe. One of the things we'd want to do is move this toroidal hole as a unit, let's say along in this direction. And that could be done by impinging the toroidal hole with a number of defects. The problem is you don't want an individual, in this case 8-edge node, to wander off by itself, or another 8-edge node to wander off in some other direction. What I think you'd need is some organization that would enable this toroidal hole, both top and bottom, to move as a complete object along, in this case, a pipe. In thinking about how the 5-edge nodes of an icosahedron might be moved together, I went back and looked at how signals flow in towards 5-edge nodes. So here's an example of single signal approaching a 5-edge node. You have the question, how does it exit the node? And the answer might be with a half probability in this direction, or with a half probability in this direction. Similarly, when you have 3 signals approaching a 5-edge node, it's fairly clear that these 2 signals want to go here, but the other signal wants to return, as you see here. The individual events at a 5-edge node can be put together in a table, which in this case has 32 rules with different probabilities. So some events have only one input and one output. Others have, in this case, 3 or 4 possible outcomes. So then I had a crazy idea. I said to myself, well, supposing there's another edge here that we could add to the 5-edge node. These 5 edges are in the fabric and have the triangular neighborhood syntax. But supposing we add an extra edge, which I called an extra dimensional structural edge. And so this has interesting implications. Now we can reanalyze how signals flow or might flow at a 5-edge node. So consider again the example of one signal approaching. Before we didn't know which way the signal should go. But now we could say, for example, that the signal goes out on the extra dimensional structure edge. And that seems like a perfectly rational solution to this single signal approaching. Here in the case where we have 3 signals approaching, before we didn't know what to do with this except to turn it around. Now we can say, oh no, it'll simply go out on the extra dimensional structure edge, and the other 2 signals will flow in the fabric as before. So we can make a table, as we did before, of the signal input and output conditions for a 5-edge node, where this area here of the table is the signals that stay in the fabric, and this line here shows whether there's a signal that goes out on the extra dimensional structure edge, the EDS edge. So in the same way that signals flow out of the fabric being the 5 edges coming into the 5-edge node here we can have a signal entering the 5-edge node via the EDS edge. And the question then is, where does that signal go? And one could say with 1/5 probability it goes in this direction, and then the same probability for the other directions at the 5-edge node. In the same way here, when we have 2 signals approaching and we happen to have a signal approaching from the EDS edge, now these signals can go as you would expect, but the EDS signal comes and goes in this direction. Once again, we can make a table of the events for the flow of signals into a 5-edge node where it has the extra dimensional structure edge. This table also has many probabilities because the extra signal can go in different directions. And here in this column we have the fact that all, in these cases, the signals are coming in on the extra dimensional structure edge. So then the question becomes, well, what do you do with these extra dimensional structure edges? So we can have here a very large fabric which consists of a very large number of 6-edge nodes and 12 5-edge nodes. And then each of the 5-edge nodes will have an EDS edge coming inwards like this. And so what we can do is put a structure of 12 5-edge nodes in the center. So this is the EDS structure as opposed to EDS structure edge. So what we have now are 2 triangular neighborhood networks, the fabric, so-called, and the EDS, so-called. EDS, the extra dimensional structure. And this is pretty nice. I mean, the only problem is that this structure here is a triangular neighborhood network, and so is this, but then these edges are extra. They're in a different syntax. The same sort of diagram can be generated for the toroidal hole. Here we have the fabric of the toroidal hole, which consists of 6 and 7-edge nodes. To make a toroidal hole, you have some number of curvatures, 12 curvatures. Let's say there's 7-edge nodes. A 7-edge node has a curvature of +1. So if you had all 7-edge nodes constructing a toroidal hole, there would be 12 7-edge nodes. If you had 8-edge nodes, you'd have 6 of them, because the 8-edge node has a curvature a positive curvature of +2, and so you'd have 6 8-edge nodes forming a toroidal hole. But in the same way we did with the icosahedron for a torus 0 structure, here for the toroidal hole we have, that is a EDS structure with 12 EDS edges coming in from the fabric to the EDS structure. I'll bring back the structure of the relationship between the fabric of the exterior triangular neighborhood network and the structure of the EDS, the extra dimensional structure. So what's interesting is that supposing you have some signals flowing along the fabric and they encounter the 5-edge node, and for whatever reason one of the signals then leaves the fabric and goes down through the EDS edge. The fabric can be arbitrarily large and has its own pace of events, but the EDS structure itself is very small. It has only, in this case, 12 5-edge nodes connecting it. So a signal entering from some random place where the 5-edge node happens to be on the fabric will come down into the EDS structure, where, because it's a triangular neighborhood network, signals will flow in a conventional fashion here, and then for some reason or other the signal may leave the EDS and go back along the EDS edge to this particular 5-edge node. So what we have here is, in effect, action at a distance, because an event that happens here can very shortly then become an event that happens here. And this is action at a distance. And I think this is logically all that one needs to be able to implement gravity as we think of it. Now, of course, we have to think in terms of much larger, much more complicated structures. We have to think in terms of the recursive nature of the triangular neighborhood system. But all of that considered, what we have now is the ability for an event here in a particular piece of the fabric at a given level to influence events far away. The only other way you'd have of influence of this events happening here influencing events happening here would be for a very slow transmission of signals or defects across the possibly great distance between this node and this node. And that is what gravity is. Now, if we consider the relationship between the toroidal hole and the exterior fabric in the case of an isolated torus, we have this sort of construct. We have the EDS, we have the outer fabric of the structure, and then we have its EDS here. This is the relationship between the 5-edge nodes, the 12 5-edge nodes that constitute the periphery of the torus, and then we have its EDS here. And then for the toroidal hole, we have its fabric structure, which may consist of 7 or 8 edge nodes and possibly 6 edge nodes, and then its EDS here. The question is, how should we relate these two EDS structures to each other? We have the problem then of having two triangular neighborhood network structures, the EDS for the fabric of the external part of the structure and the EDS for the toroidal hole. As I've not done simulations for this notion of the extra dimensional structure, I really haven't been able to say what to do. Should these two, in this case, icosahedral structures, be isolated and just work by themselves, or should they be connected? We'll explore that in the next section. Here we have an isolated torus 1 that consists of the external structure that closes the torus that has 12 5-edge nodes in it, and then the interior structure of the toroidal hole that has 12 7-edge nodes in this case. We saw in the logical diagrams that there are two EDS structures, one EDS structure for the external fabric of the torus 0 and another EDS structure for the toroidal hole. The question is, should these EDS structures function in isolation from each other, or should they be combined to work together? So here's the concatenation of the two EDS structures through two triangular faces. The nodes here are all in one region, and the nodes for the here are again in the same region. Because these are because these are triangular neighborhood structures, we can do edge rotation on them, and the structure like this might exist at some point or another. But still, you see all of the nodes associated with the fabric of the exterior portion of the torus are in one region, and the nodes associated with the toroidal hole are in another region. They do communicate with each other, and so you could have an event coming in from the fabric of the exterior of the torus, going through this structure, and then leaving through a toroidal hole edge, and that may have some function or utility. I don't know, but it doesn't. That's about the only feature that recommends connecting these two structures together, is that a signal coming in here could exit through here. And so I think that's probably what's going to happen. But now, whether this structure, either one of these structures, can be connected to yet another EDS structure through some interface, well, that's not at all clear, and I'll try to discuss that in a moment. Now, if we connect the torus 1 to the ground state, which can be a large array of 6-edge nodes, or it could be a pipe constructed like this. In any case, what we've done is we've introduced a new toroidal hole connection with new curvature, positive curvature. So there'd be a positive curvature of 12 here. And as a result, it'd be an EDS associated with it. So the question is this EDS connected to the EDS of the toroidal hole and the associated torus 0 closure of the toroidal hole into a torus 1? So we couldn't decide also whether these EDS structures are connected, let alone the question of whether these EDS structures are connected to this EDS structure. And then, of course, if this structure here were part of a larger system of a pipe or whatever, how is this EDS connected to the other EDS structures here? At the first level of structure for a triangular neighborhood network, a torus 0 has 12 5-edge nodes. If we include the notion of the extra-dimensional structure, then from each of those 5-edge nodes comes one edge that goes together to form the extra-dimensional structure. The extra-dimensional structure at the center of an icosahedron is itself a triangular neighborhood network. You've seen in the past video when I talked about second level structures, I showed you the construct for the second level structure for a 5-edge node. This is the banded pipe version of that structure, and it had one of the so-called Chevy Chase circles in the middle. What I've done now, given the EDS idea, is I've concatenated in a pipe that will represent the second level structure of the EDS edge. So, and this is true because the EDS edge is part of the triangular neighborhood recursion, and so at every level we can take the EDS edges that are generated, and at the next level of structure below we can represent each of those edges as a pipe of some construction. This happens to be a 3-pipe parallel. You'll remember also that there was a vertical pipe implementation of the second level structure for a 5-edge node. It too had one of the toroidal holes in the center, which I called a Chevy Chase circle. And now what I've done is I've added to this a pipe, a three pipe, parallel structure pipe that has the effect of representing the EDS edge at the previous level. So independent of the style of implementation of the second level structure for a 5-edge node, the EDS edge can be implemented as a pipe at that level of structure. The same thing would be true for 7-edge nodes. I'll show you that in a second. You may recall from the video on the second level structures for triangular neighborhood networks, I tried to make, in fact, two different structures for the second level structure of a 7-edge node, and neither one of them were very successful. This is the vertical pipe version of the 7-edge second level structure for a 7-edge node. I wanted to put a pipe section here, and I could have done that, but I realized that actually the way the 7 edges work, they always face like this, and that the EDS edge would be more, I don't know, almost from here, going down to the center of where the toroidal hole would be. So I tried, this is a 7 pipe, and this is a 14 circumference outer circle here, and I tried to reduce the 7 pipe to a 6 pipe, and this 14 to a 12, and I figured, oh well, I could get a solution there. But I just finished trying that, and it doesn't seem to work, so I'm still no place. So the important thing is that whenever I find a solution to the second level structure for a 7-edge node, probably the EDS edge will come out like this, but that's not important. I mean, it's a problem, but it's not important. What's interesting, of course, is that this 7-edge node, when the second level structure is constructed, it's really just a TNN. It's just a triangular neighborhood network. There's nothing special about it. I mean, I don't have the solution yet, but that's just the problem. With respect to the position of the EDS in the structure, let's say, of a torus 0, in principle, this EDS structure could be any place inside of this bag or outside, but let's just say inside. That's one thing. In the case of the torus that has the two EDSs, one for the external torus 0 and one for the toroidal hole, if you want them connected, probably you will put them here. Of course, it could be here, but then this EDS would have to be operating completely alone. But if the two EDSs are connected, there's the question of how an EDS edge from the torus 0 can get through the structure, the fabric of the toroidal hole. And that brings up the question of how pipes pass each other, because at the second level of structure of the EDS edges, there'll be pipes, and so you have the question of how does one pipe pass through another. This logical diagram is meant to illustrate how two pipes pass through each other. So if we have pipe A and pipe B, I mean, this thing is better in 3 dimensions, but I think this is enough to explain the idea. You can't just pass them through each other. You would have to bring in a pipe, a toroidal hole, from someplace in the exterior of the structure, and that toroidal hole would move to a position like that. And then the toroidal hole could shrink into a contact of the two pipes, shown here, and then this is the transition point, and then the two pipes could re-emerge, but here A would be on the right of B, and then the pipe would go away, and now you'd have two pipes that are have passed through each other. So this is the general logical description of how two pipes pass through each other. And this should be ordinary within the respect of the triangular neighborhood networks. The difference, of course, is that you have to have this extra pipe in order to accomplish the transition state. Having built the EDS structure for a torus, we can now apply that concept to something larger, for example, a galaxy. So a galaxy is characterized in many cases by a toroidal hole at its center. Now, whether the toroidal hole is causative or only merely a property of the galaxy is not clear, but the notion in the triangular neighborhood networks of a bag and then a toroidal hole at the center is quite ordinary and simple. This bag could be filled with all sorts of other objects, stars, whatever, and dust. The logical structure is quite simple. We have a torus zero on the outside acting as the container for the galaxy. We have the toroidal hole in the center, which acts as some perhaps motive force for the rotation of the galaxy. And then, of course, we might have connections out here in various places that connect this relatively isolated structure, the galaxy, to other galaxies and to the whole universe. So the construction of this galaxy model is with respect to the triangular neighborhood networks quite ordinary. Now, whether these are EDS structures are connected to something else, that I still haven't resolved. So let's discuss once again the question of whether the EDS structures are connected or not. I showed in the previous sections that it's certainly possible to connect the EDS structures of a torus one. We'd have the EDS for the closure, the bag, and then the EDS for the toroidal hole itself. But now let's discuss the question of how you would take this torus and connect it, let's say, to a pipe. I mentioned before that you need, I showed in the structure, a pipe connecting the torus one to a pipe, and that would induce an EDS also of 12, a toroidal EDS, because it's a toroidal pipe that connects the surface of the torus to the surface of the pipe. And then, of course, the pipe, which is part of a larger triangular neighborhood structure, itself would have an EDS. And the question is, what do you really want to achieve? Well, in terms of the torus, the EDS of the outer surface could change the shape and size of the torus, which of course is interesting and on occasions important. The EDS for the toroidal hole can change also as a function of the shape of size and shape of the outer surface. We've seen many different toroid in the previous videos, and so changing the way the positive connectivity of the toroidal hole is organized is one of the functions of this EDS. And of course it can be done independent, not quite independent, signal dependent on the behavior of the 5-edge nodes that constitute the closure of the outer surface. So in a certain sense, instead of arguing that they're connected, I think I'll argue now that they are actually independent. And if they're independent, well then this EDS here for the outer surface doesn't have to be in the inside. It can be anywhere, but it could be inside the volume of the outer surface of the torus. So we could change this picture a little bit if we wanted to. In the same way, if we have a connection between the torus and the pipe, Well, one of the goals clearly from the viewpoint of signal motion is we want to be able to move this torus along the pipe in either direction, of course, since the torus, one, is the embodiment of a signal at a higher level of structure. So you want this EDS here to also be acting independent of anything that the bag is doing or the toroidal hole here are doing. And in the same sense, this object, the pipe itself, is part of a larger context which may be involved in edge rotation or defect motion or God knows what. But when this edge moves, rotates, for example, in its larger context, I think you'd want to carry along the structure of where this thing is in relation in the pipe, and then what the rotation of the torus 1 is with respect to the orientation of the pipe. So this, the conclusion I've come to now is that these EDS structures are independent. I mean, they exist for each level of structure, that's for sure, because at each level of structure there are new toroidal holes, either a certain number at a given level and more, generally speaking, when you go down a level. So that's the conclusion I've come to. I hadn't resolved that problem until just now, as I'm working my way through this video. But now I think it's fairly clear. So this diagram just shows the idea, once again, that the pipe with the mobile torus 1 on it can be embedded in a larger system. That should be fairly clear now. An earlier video showed how edge rotation causes a pair of defects to be formed. So when this edge rotates from this context to this context, then we get the formation of 2 7-edge nodes and 2 5-edge nodes. And these are a pair of defects, whether this defect goes this way and this defect goes this way, or whether this defect goes this way and this defect goes this way, is a matter of local control. But in any case, the defect pair is embedded in a hexagonal fabric. There was the question of whether something like an event like this should be formed, or could it be formed? Because in principle, well, there needs to be some trigger, and I don't think I've found that yet. But supposing that question was resolved, now that we have the EDS idea, we could consider that when this edge rotation occurred, that a tetrahedral EDS was formed. Unfortunately, the forming of this set of 4 nodes, the EDS structure for this defect pair, violates the question of the conservation of toroidal hole. So I've not resolved that question. But let's say that question could be resolved. Well, in that case, as this defect moved off here, and perhaps this defect moved off here, then these 2 defects would be entangled by the EDS. And you would have instantaneous, well, virtually instantaneous, because when a signal entered, let's say the defect was off someplace here. So when a signal enters the 5-edge node and happens to come down into this micro EDS here, and then it goes around through a very small EDS, then it could pop out again on one of the EDS edges, either at the 5-edge node here for this defect or the 7-edge node. So that would qualify as basically instantaneous. That's really very exciting. I mean, this is, in a certain sense, a tremendous new possibility for the triangular neighborhood networks. It explains how entanglement occurs. Now, I haven't solved the problem of when does edge rotation occur, nor have I solved the problem of how to get this EDS to either come into existence or to prune itself off from some other larger EDS structure. Those problems I haven't resolved. But let's say we could resolve those problems. That would really be very, very, very neat, I must say. Let's first look at the structure of a pipe. The pipe can be as long as it wants, and a pipe will have an EDS that has 12 5-edge nodes, and the EDS edges connect to 12, let's say, 7-edge nodes. The important thing about the pipe is that it can be as long as it wants to be. And when a signal enters the EDS edge, let's say at this 7-edge node here, it comes to the EDS of the pipe, circulates around through that, and then perhaps at some other point will leave the EDS and go back to the fabric where it then emerges in the fabric. So the distance between here and here can be extremely long. That's important. So now if we add the toroidal hole to the pipe, it looks something like this. The toroidal hole will have a fabric of its own with 12 7-edge nodes and an EDS of its own. The goal, of course, is to move the toroidal hole along the pipe. If we then look only at the structure of the toroidal hole, the insight that I had just recently was that perhaps the EDS of the toroidal hole could be more complex than previously imagined. Previously, we thought only of having the EDS edges go from the 12 7-edge nodes that form the curvature that allows the toroidal hole to exist. But now if we posit that there are sets of defects on the periphery, there can be as many as, let's say, 12 defects. I don't know the number. But each of these defects are 5-edge and 7-edge nodes, and they would have EDS edges as part of the EDS structure here. So the question is, how do you do that? You can't have more than 12 5-edge nodes, but as we've seen, as we've built these small structures with 6-edge nodes in them, you can have any number of 6-edge nodes. And so we'd have an EDS structure here that had not just 12 nodes, 12 5-edge nodes, but would have some number of 6-edge nodes. And so this is very interesting because once again the signals could come into the 7-edge node of the fabric, in the fabric of the toroidal hole, and go to the EDS and then go across at some point and out the other edge if we want. But the defects also could have signals come into them, come over the EDS edge to the EDS structure, and then go out some other direction. So this is my idea at the current time for how the toroidal hole might move. That is, these extra sets of defects which are tied to the EDS of the toroidal hole could help to organize the change around the periphery of the hole and possibly move the hole in some particular direction. I haven't simulated this yet, but at least these concepts exist now, and one could then do a simulation and see whether the ideas have any utility. Another important problem has been the rotation of edges in the triangle neighborhood network structure idea. So first of all, I need to make a simplification. So if this is the a pipe, and this is its EDS structure, where the curvature nodes of the pipe are interfaced to the EDS structure by an EDS edge. If we represent this whole structure by a simplified thing where this represents the pipe and this represents its EDS structure, and then we can go on to deal with the problem of edge rotation. In this diagram, we use the simplified pipe structure with its EDS in representation to construct two triangular neighborhoods. This triangular neighborhood and this triangular neighborhood. This is the second level representation where each of these elements is a pipe. So this is the starting context, and we want to use the EDS here in this edge to be able to activate the ends of this pipe, which would be in a node of some construction. Could be a 5 or a 6 or 7, whatever, on either end. You don't really know. But what would happen is that there would be a transition state in which this edge would move in this direction, let's say, and this part of the edge would move in this direction. So we go from this state to this state here. And then a little bit later, with more motion on the part of the edges, we'd be in a state like this. And then finally, the edges would move in this direction here, and this edge would move in this direction. And now we have the transition. So this is the way that, or at least a representation of the way that the EDS of an edge at this level, a pipe, would be able to activate the ends so as to cause motion in the ends of the pipe along another pipe here and along another pipe here, and that we get these two transition states, and then finally the terminal state in which the edge had been rotated. The idea of using second level structure with entangled defects to activate the ends of a pipe so as to be able to cause this edge rotation motion is a very important idea, and needs to be simulated, of course, but will possibly yield a solution to how edge rotation occurs in the recursive aspects of the triangle neighborhood network idea. The summary for this video on gravity brings the following points to forward. The extra-dimensional structure idea provides a mechanism for action at a distance at all scales and all levels of the triangle neighborhood network structures. The individual EDS TNNs structures act to organize change on a local basis. A given feature, that is to say a torus zero hole or a toroidal hole, is part of a hierarchy of recursion, and changes in the structure of this feature can have more than local effects. That's very interesting. And then the possibility that defect pairs may be entangled over long distances at a given level, and possibly even across levels, is really very new and dramatic.